Okay, so we're going to be working on the 5 exponential and log questions next. Solving these things, it says we can use a calculator, even though on some of them we don't need to. Whoopsie. So we're going to start by this one. 4 times e to the x equals 24. So our first step is going to be divide everything by 4. And to save space, I'm going to be working up above. So e to the x equals 6. And now we're stuck with trying to get the x out of the exponential. And to do that, we natural log both sides. Okay, that's how you get rid of, well, actually, the exponent would come in front. That's one of the properties of logs. But the natural log of e is just 1. So when we natural log e to the x, the answer is just x. So the answer is the natural log of 6. Which, if you type into your calculator, natural log of 6, we get 1.7918 as the answer rounded to 4 decimal places. Okay, so moving on, the first thing we want to do is get rid of this 5. So we divide both sides by 5. 3 to the 2x power equals 70 divided by 5. I should know that in my head. 14. And here we have your variable in the exponent. So once again, we need to natural log both sides. Now, that of course allows us to bring the 2x, our variable, or your exponent, to the front. So 2x times the natural log of 3 equals the natural log of 14. Okay, so we can just divide, in this case, by 2 natural logs of 3. Those are both numbers. Natural log is a decimal number. So if I divide by 2 natural logs of 3 over here, make sure you use parentheses when you put this in your calculator. 2 natural logs of 3. I get 1.2011 as my answer. And of course, you can always plug it back in and do 5 times 3 to the 2 times 1.2011 and see if you get something close to 70. And of course, you should get something close to 70, maybe not exactly, but something close. Okay, so now here is a log equation where we have log on one side. So when we have log on one side, you want to rewrite that equation as an exponential. Okay, when there's logs on both sides, you can just cancel out all the logs and you'll be good after you condense. But we want to solve this as an exponential. So that would be base, the base is 4, raised to the 7th power is going to equal 2x minus 1. Okay, so when log equals a number, we rewrite that as an exponential, where the base of your log is the base of your exponent. Now, 4 to the 7th power is 16,384, my calculator says, equals 2x minus 1. So I'm going to add 1 to both sides and then divide by 2. Sorry, I'm not going to write that down. But the answer turns out to be 8,192.5 would be the value of x. That makes this a true statement. Okay, so this next one, I also have log equals a number. And without any number down here, I'm supposed to remember that that's called a common log, which has a base of 10. So there's no base down here, so that means it's a common log, which has log base 10. So 10 to the 6th power equals x squared. And I'm going to actually evaluate this and then take its square roots all at one time. So the square root of 10 to the 6th power is 1,000. Which makes sense, that's 10 cubed. Okay, so to this one, I'm going to first divide both sides by 4 because you don't want to have anything around your natural log. So the natural log of 2x equals 3. A natural log also has a special base, and that base is e, and it will never be written there. So you're going to have to remember natural log is log base e. So e to the third power equals 2x. So this is going to go in your calculator. E to the third divided by 2. E to the third power divided by 2 into the calculator, and we get 10.0428 as the fourth decimal place rounding of these. Okay, so when we have log equals a number, you always solve them by rewriting it as an exponential, where the base of your log is the base of your exponent. This becomes your exponent, and then this is what it equals.